Welcome back, friends. In the previous session we had an introduction about the boiling point elevation as one among the colligative properties, and in this session we are going to continue with our discussion regarding the molar elevation constant for boiling point and the different solved example in the boiling point elevation. Now let's start discussing with the molar elevation constant. Molar elevation constant Kb. So the molar elevation constant Kb is sometimes known as the ebullioscopic constant. Ebullioscopic constant. Ebullioscopic So what is an ebullioscopic constant or the molar elevation constant? Is defined as the boiling point elevation produced when 1 mole of non-volatile solute is dissolved in 1 kilogram of solvent. Remember, we said that the change in boiling point or the boiling point elevation is directly proportional to molarity of the solution. So the ebullioscopic constant is the boiling point elevation produced when 1 mole of solute, remember we said molarity M is equal to number of moles of solute divided by mass of solvent in a kilogram. So the ebullioscopic constant is the elevation of boiling point when 1 mole of solute is added in 1000 grams of solvent. That is to say, 1 kilogram of solvent. So if we have 1 mole of solute added to 1 kilogram of solvent, the elevation of boiling point produced is called as ebullioscopic constant, and this elevation always remain constant. Tunapo add 1 mole to this, tunapata volume constant. Now from there we say elevation of boiling point is that proportional to molarity M, or in other words, elevation of boiling point is equal to constant K, then from there we'll have M. So K is the constant of proportionality, and in our case, is the molar elevation constant Kb. So change in temperature will be equal to Kb, then molarity M. This Kb is an ebullioscopic constant. So ebullioscopic constant Kb is the property of solvent. Hiyo kila solvent inakuwa na Kb yake. Is the property of solvent. So its value depends on the nature of solvent and vary from one solvent to another. Since boiling point elevation varies directly proportional to the molar concentration of solution, therefore, change in temperature T is directly proportional to M. So change in temperature T itakuwa sawa na Km, but K is the constant of proportionality ambayo inaitwa ebullioscopic constant Kb. So to get the equation, change in temperature is equal to Kb, then molarity of solution M. From there, we are saying that but molarity, as we say, molarity is equal to number of moles of solute divided by mass of solvent. So molarity M, number of moles of solute divided by mass of solvent in kilograms. So tunachokuja ukipata kwenye nini? Mass of solvent tunahitaji iwe kwenye kwenye kilogram, ambayo kwenye kilogram, if this mass is in gram, mv must be in kilogram. So if we are given mass in gram, tunaifanyaje? Mass in kilogram which is mv itakuwa sawa na mass in gram gawanya kwa ngapi? Kwa 1000. Unaona, ili tutoke gram tuende kwenye kilogram. Sasa kama kuchukua mass kutoka kwenye gram kwenda kwenye kilogram, tunagawanya kwa 1000, maana yake hii hapa tuje tuingiza, itakuwa m ni sawa na number of moles of solvent gawanya kwa ile mass tuliyopewa kwenye gram, tukagawanya kwa ngapi? Kwa 1000. That means hii ni division of fraction. That is to say it is NS then divided by mg gawanya kwa 1000. Mg ni mass of solvent in grams. So you get NS then times 1000 divided by mg. That is to say number of moles of solvent mara 1000 gawanya kwa mass of solvent in grams. So taking this equation then inserting it here, we will get change in temperature is equal to Kb, number of moles of solid times 1000 divided by mass of solvent V. So our equation ambayo tutakuwa tunaitumia itakuwa inaonekana kama hivi. Itakuwa inaonekana kama namna hii hapa. Hii hapa ni number of moles of solid. Lakini pia we can still manipulate our equation. We can still manipulate it. Tuna manipulate vipi? Tunasema but number of moles of solvent is equal to mass of solvent gawanya kwa molar mass. Of solid. Number of moles of solid ni mass of solid gawanya kwa molar mass of solid. So from there tutapata, tukiinsert hapa tutapata change in T is equal to Kb mass of solid mara 1000 divided by mass of solvent mara molar mass of solid. This is the last equation ambayo ndio tutakuwa tunaitumia kwenye most of our calculation. Remember, change in temperature is sawa na boiling point ya pure liquid. Boiling point ya pure liquid. Boiling point ya solution minus boiling point ya pure liquid. Kwa sababu hapo boiling point ya solution ni higher. So this is a boiling point elevation. Boiling point ni higher. Kwa hiyo boiling point ya solution itakuwa kubwa kuliko ile ya pure liquid. From there, hapa maana yake ni kwamba hii ni hygroscopic constant. Hygroscopic constant, mass of solute, mass of solvent, molar mass of solvent. Let's solve the examples in this part. Solve the examples. So in our question, we are told that the boiling point of a solution containing 0.2 grams of substance X in 20 grams of ether is 0.17 Kelvin higher than that of pure ether. Calculate the molecular mass of X if the boiling point constant of ether is 2.16 Kelvin. So the question is kwa sababu hapa tuna data tayari. So data given, we are given a mass of solute MS is equal to 0.2 gram. We are given a mass of solvent LV is equal to 20 grams. We are given change in temperature, boiling point elevation, boiling point elevation is 0.17 K. Toka hapo tumepewa KB 2.16 Kelvin. From the formula, change in T is equal to KB mass of solute gawanya kwa mass of solvent. Molar mass of solute will be is equal to KB mass of solute so hapo tukiingiza utapata KB ambayo ni 2.16, mass of solute ambayo ni 0.2, mass of solvent ambayo ni 20 grams, na change in temperature 0.17. From there utapata 2.16 times 0.2 times 1000 divided by 20 times 0.17. So utapata molar mass of solute ni 127 gram per mole, 0.05 gram per mole. So simply jibu lako linakuwa kama hilo hapo. Kwa maswali yanakuwa yanatoka kwa namna kama hiyo hapo. Maswali yanakuwa yanatoka kwa namna kama hiyo hapo. And then from there let's move to example number 2. Example number 2. So this is our example number 2, which we are required to solve. And in our example, we are given acetone boils at 56.39 degrees Celsius and a solution of 1.41 gram of organic soil in 20 grams of acetone boils at 56.89. If Kb for acetone for 100 grams is 16.7, calculate the mass of 1 mole of organic solids. We are trying to calculate the mass of 1 mole of organic soil. So tutakachokifanya hapa tutatumia data kwanza tulizopewa. So data given tumepewa boiling point ya acetone, boiling point ya acetone TB sawa na 56.38 degrees Celsius. Then tumepewa boiling point of solution yapo sawa na 56.88. Then tumepewa mass of solute mass of solute 1.1 gram, and then tumepewa mass of solvent 20 gram, and then after that tumepewa Kb for 100 gram. Kb, remember this is for 100 gram, iko sawa na 16.7. So from there we are going to calculate mass of 1 mole of organic soil. Remember, mass of 1 mole of a substance is called the molar mass. So from there we are saying from change in T, mass of solute, Kb, mass of solute. Now in our case, we are given Kb for 100 grams. In all cases, mara nyingi tunapewa Kb for 1000 grams. So tukipewa for 100, we are multiplying by 100 and then divide by molar mass of solute times mass of solvent. So making the subject molar mass of solute from our formula, we'll get molar mass of solute is equal to Kb mass of solvent times 100 divided by change in T Mv. But change in T is equal to boiling point of solution minus boiling point of the pure liquid Tb. So in our case, we can just go directly solve the final answer for the question. Tutasema change in temperature sawa na 56.88 au 56.38. This will be equal to 0.5 degrees Celsius. and from there molar mass of solute itakuwa sawa Kb 16.7 mara mass of solvent 1.41 times 100 divided by change in temperature 0.5 times mass of solvent 20 grams. Solving for this in your calculator, so 16.7 times 1.4 times 100 divided by 0.5 is 20. Tapata 235.47 gram per mole. So mass of 1 mole of organic solid is 235.47 gram. 235.47 gram. So yeah, toka hapo swali linalofuata, swali la 3. Swali la 3 swali la 3 ngoja niandike hapa. So in this question, 2.1.41 grams of solute of molar mass 320 are dissolved in 500 grams of water. Calculate the boiling point of this solution. So the question is very easy. We are just taking data given. Mass of solute 2.7 gram. Mass of solvent 500 grams. Molar mass of solute 320 grams per mole. Kb 1.86 degrees Celsius per L. From there we say, in swali data ndio from there tunasema from change in T KB mass of solute. Hapa tunazidisha mara 1000. Kama hujaambiwa KB is for 100 grams, unazidisha mara 1000. Na ukipewa KB ambayo iko kwenye unit hiyo hapo unazidisha mara 1000. So tunagawanya kwa hapo tutapata KB mass of solute 2.41 mara mass of solute 320 mara. So change in temperature itakuwa zero pointi 0.029 degrees Celsius. This is change in temperature. Remember, we know the boiling point of water. We know the boiling point of water is 100 degrees Celsius. So we'll say from change in temperature is equal to T minus TB. Then T will be equal to change in temperature plus TB. So T will be equal to 0.0279 plus 100, which will be equal to 100.0279 degrees Celsius. This should be the boiling point of the solution. If you approximate it, you get 0.028 degrees Celsius, the boiling point of our solution. Boiling point of our solution. And then the last question in this part. So this is our last question in this part, and in this question we are asked that through an experiment 1.35 grams of solute were dissolved in 72.3 cm³ of water, and the solution was found to boil at 100.162 degrees Celsius at 1 atm. Then calculate the molecular weight of the solid, given that Kb is this one. So the question is easy. It is comparable to the one among the question which we have already discussed about require Kb ikiwa na 100, and we said in our formula to multiply kwa 100. So about the mass of solvent, don't worry. We know the density of water is 1 gram per cm³, so we convert that volume into mass by using the density of water. I will left this question as part of your quiz, and we will submit this in my Telegram as part of your quiz. Well, you must reach with the answer, which is 59.935 gram per mole. That's the final answer for this question. So just do this question and make sure you are reaching the final answer, which is this one. In the next session, we'll discuss about the freezing point, depression, and the other colligative property. Thank you, and let me wish you nice studies.